Hello, my name is Yueru. I'm going to present machine learning techniques of twist analysis using customer service data of airline companies. As companies become globalized and digital, many companies have been successfully applying conversational artificial intelligence in customer support service. Today, more companies are having their official Twitter accounts to support customers. In this project, I collect real-time customer support data on Twitter from companies of American Airlines and United Airlines between November 8th to November 17th, and ended with 8348 rows for American Airlines and 5232 rows for United Airlines. The feature I used in this project is only twist content. The first goal of this project is sentiment analysis. Based on response from users, we could conclude which companies do a better job in terms of providing customer service on their Twitter accounts. In this part, I used TextBlob library in Python to get polarity and then label them as negative, neutral, and positive. As my original data is unlabeled, so I use the results from TextBlob as pseudo-labels, and then implement a LSTM neural network model using GloV word embedding. The second goal is doing topic modeling to group and extract information in all negative tweets from users. I use three methods in this section. First is key means clustering using word embedding, then LDA approach using word embedding and term frequency separately. First, I clean the twist data by removing numbers, punctuations, and stop words, and create a bag-of-word model. Find most frequent appearing words and plot word clouds. From word clouds, we can get a general understanding of the twist data. We can see some top frequent words like thank, help, hour, time appearing in both companies, and most words are good and neutral. For sentiment analysis, I use TextBlob library in Python and keep all information in twist. As TextBlob has semantic labels for emoticons like an exclamation mark, emoji, and so on. I use polarity returned from TextBlob to classify the tweets. When the score is greater than 0, it's positive, less than 0 is negative, otherwise it's neutral. The results show that there are lower percentage of negative tweets in United Airlines, whereas higher percentage of positive tweets in American Airlines. In general, customer service of United Airlines on Twitter performs slightly better than American Airlines between period of November 8th to November 17th. Next, for the LSTM neural network model, I first convert label into three dimensions where each position corresponds to a sentiment class. Then, I start with a simple implementation of LSTM with few basic layers, and the accuracy is just 0.578 at the beginning. Then, I tune the hyperparameters and add more layers. When adding a bidirectional LSTM layer and blend GloV word embedding into the model, the accuracy of the model improved dramatically from original 5.78 to 0.875. Here is the error analysis for LSTM model. We can tell the model performs very well from the true predictions in diagnosis. There are 6 types of errors. When looking into these predictions errors, I found the common reasons for these errors are first, because my labels are results from TextBlob, meaning not all of them are classified correctly. In the first example, the text block classified the twist as a positive, but the LSTM model predicted as negative. Actually, the LSTM model predicts better than text block in this case, as the customer is going to rebook on a different airline, and thus the customer is probably not happy with the results. In the second example, the text block classified the twist as negative, but the LSTM model predicted as positive. The result for that is because this twist is complex sentence and has some unrecognized words, so it's hard for both models to analyze. In the third example, as I used clean twist for LSTM model, some strong sentiment words are removed from the model, like can't, don't. Therefore, the LSTM model predicts differently. Next, let's move on to topic modeling. As my data is unlabeled, extract topics from negative twists would be something interesting to explore. This would provide some insights to airline companies understanding what are customers complaining about and improve their service quality on Twitter accordingly. The first method I implemented is k-means clustering using word embedding. An experiment with different key and one key equal 4, the topic cluster seems to be the best. Then I plot the top 15 words in each cluster. From these keywords we can tell in cluster 0, it seems like users are complaining about waiting hours. Cluster 1 is similar to cluster 0, but this group contains words like delayed and delays that make this cluster more specific. In cluster 2, except for the flight delays, customers also complain about bags and their experience. Maybe customers lost their baggage or having a bad experience with the flight. In cluster 3, customers probably complain about company's mileage rewards program. Then I use the LDA method on embedding to model the topics from the tweets. LDA assumes that each tweet is made up of several topics with a different probability distribution, and each topic is made up of several words with a different distribution. So we see many same words appearing in different order in each topic. This is the key difference between LDA and clustering. I feed the GloView word embedding data into the LDA model and extract top 15 words for each model to see what topic LDA extract from. I experiment with different numbers of topics, and when n equal to 4, the model performed the best. From the result, we can see the first topic from LDA model is mainly about delayed flight. Second is about flight time. The third topic is more about customer service and hours. And last one is about gate, airport, bag, and the delayed flights. Finally, I tried the LDA model with word frequency instead of embedded word. Due to time limitation, I will not elaborate it here in this video, but the results are similar as previous methods. In conclusion, in this project, I scraped real-time twist data from companies of American Airlines and United Airlines, and implement sentiment analysis for customer questions or replies on Twitter. Then, I used the results from sentiment analysis as a pseudo-label for LSTM neural network model. Because they are not real labels, so predictions from the neural network model are just an approximations. Then, from topic modeling, I can conclude that the most prevalent topics from these three methods are almost same, with a slightly difference in each topic. The main topics that customers complain about are delayed flights, waiting time, baggage issue. Some possible topics that not appearing in all approaches are mileage rewards for hotel and travel, and also money refunds. Limitation and future work in this project are first, for the LSTM neural network model, as I use sentiment label, so the result is actually not meaningful. However, the final model performs very well and could potentially used in the future similar projects. Second, the size of the dataset is not large enough. Considering the computing power of my computer, I only used 1/30,000th of twists in the project. We could increase the size of twists so that improving the specification and intelligence of topics. And last, improving the quality of cleaning twists. This could also help to obtain good topics segregations. So this is all about my project. Thank you.